because it's where the polymorphism is, where the generic plugin is casted into the concrete classes. And it's actually very simple. It's just discovering the type of each plugin, which is an attribute of CMS plugin base class, and then doing a query set per type. So it's still a bit expensive, but less expensive than hitting a lot of tables and doing a lot of joins. So thanks to the ORM, it's actually not complicated to do this. Things get a bit more complicated when you try to copy plugins, because you are almost in a catch-22 issue. You need to update the tree information on the plugins you are creating, which are handled automatically by Treebird or MPTT when you save the plugin, but you may have required fields you don't know anything about in each concrete model of the custom plugins. And so we are in the Mexican dual situation. We have the tree here, we have the required fields here, and we are here. So the question is how to clone the model-specific data of a model without knowing its structure and let the MPTT Treebird create the tree data. Well, we use the ORM. It's actually pretty simple when you start thinking about it. Thanks to the way Django handles the ORM, we can create a generic plugin here, assign all the generic attributes, the placeholder, the parent, the language, the plugin type, and yeah, caching it. As I said before, we try to cache as much as possible in local functions and local attribute, and then save this generic plugin. When you save this, the tree data are created because the position of the plugin into the placeholder is fixed. So you have all the information and the tree is created. So one step is, one goal is achieved. Now we have to clone all the data we don't know anything about. We can do introspection eventually, but we can use this trick from the ORM to do the same thing without cycling over the fields. What we do here, this plugin instance is the source plugin, okay, the plugin we want to copy. Then we have this new plugin, which is the plugin we just created in the new position of the plugin. If we assign to the old copy the primary key of the new one, and we have to be careful about because we have to override ID, PK attribute, and the one-to-one field, which links the generic plugin to the concrete one. This plugin instance is not the source plugin anymore, it's the target. Then we can just scroll a bit down here. We can just copy the tree attribute we created on this plugin, and then when we save the previous source plugin, now the target plugin, we end up having the same tree information of the generic plugin before, and all the data copied automatically by the Django ORM. So it looks like a trick, but it works, and it's working surprisingly well for a very long time. Actually, this code has seen some improvements in the last few years, but doesn't change the way it worked really. But yeah, the point is that the Django ORM is very flexible, and you can do apparently weird things with it with a good chance of reliability. And then we are at question stop number 2.
So one question that was asked by a couple of people is, why do you have draft and live versions rather than a revision history?
We also have revision history, but the thing is that picking the live version from revision would be very too heavy. In this way, we have exactly the same load of retrieving the draft version, which is the version the people works on, so it has to be concrete models that people can use, and a live version which is very easy and quick to parse and to create. So that's Django CMS also has revision support by using Django reversion, and but it would be very heavy to rely on it only for the publishing.
So it allows you to optimize the two most common use cases.
Exactly.
Wouldn't still get the rest of it working. Cool. Can you talk a little bit about the performance implications? Like, is there, should you not have too many nested plugins? Like, is nesting plugins more expensive? Is having too many plugins expensive? What happens with that sort of performance story?
Yeah. Well, actually, the most performance-heavy part of Django CMS is not shown in this talk. It's the menu, which is really the heaviest part. So in comparison, the plugins are not really an issue. One point is for content-centric websites, you will end up using cache every time. And especially, sometimes you will cache the entire page in Varnish or Nginx cache, and you will forget about the rendering phase. So yes, it's a bit heavy, but we try to do the most possible things to not do anything on the back end, so to not hit the penalty, the performance penalty.
Okay. With that sort of like performance sort of things in mind, obviously things like Varnish or Nginx caching or whatever are great solutions to deal with that problem in a very sort of like solid way. Is there any suggestion of having something like a static site build out or something that you can configure your thing and then just push some static files, for example?
I know a few people who use Django CMS to generate a completely static website. I don't know of any application that makes this easy or that helps you in this process, but in the end, you can just build a website, pass wget to it, and staticize it completely. But yeah, for some websites, it's a perfectly reasonable solution to have a completely static website.
I'm going to read this question verbatim because I don't completely understand it, as I don't use Django CMS very often. Say you have a plugin type that's added to a page, and you want to add this very same instance to another page, but styled a bit differently, i.e. a different template. How do you reuse that content without deleting the published version on every update?
You can't. So it's a very bad practice. If you work at very low level, it's possible to reuse the same instance in more than one place, but don't do that.
Okay. Final question for this section. Django CMS seems to use a bunch of tricks for polymorphism and trees and so on. Is there some scope for Django to improve its support for those kind of things, or do you find that the third-party packages you have work well enough?
Well, for the tree part, I think that the existing solutions are quite good. We recently moved from MPTT to Treebird. Yeah, having a tree solution in core would be very, very nice, but probably is out of the scope of Django, of the Django framework. And yeah, probably what would be super useful would be a generic framework to deal with draft live, with publication of items. But again, I still think it's a bit out of scope. Probably with polymorphism, the ORM can provide more a nicer way to do this. This probably can be an area of improvements. I don't have any specific ideas how to improve the things currently, but it's a thing that may help. Since we started doing this in-house polymorphism, a few Django applications that handle polymorphism exist. At this point, the pain of rewriting the existing code is much higher than using what we already have.
Okay, lovely. Thank you very much. Part 3.
And now the ugly part. And the ugly part is the URL conf. Just as Jacob told before, there is no way to cleanly extend or replace the resolver, the URL resolver, but Django CMS has to do this because using Haphooks, it tries to make applications pluggable dynamically into the global URL conf. And this is not a nice part of code, but let's see first how Haphooks work. Haphooks is very tiny class. The simplest one is this one. It's just a wrapper around the URL conf of an application. When you create this class, Django CMS loads and registers this class, and then you have this class available on the page change form. So you can add the Haphooks to the page and say, okay, this page has an Haphooks attached to it, so it has a URL conf attached to it, and then the URL conf here is injected into the global URL conf, and then the magic that Jacob explained before happens. So what we do here, because we cannot extend or provide our own URL resolver, is to create dynamically a bunch of basically URLs, and on these URLs we can apply a custom URL resolver. So the first phase, which is in these lines and before, is to retrieve the Haphooks, which are just strings in an attribute in a page. And so we get the application namespace, the instance namespace, and the patterns. So the pattern the page matches, and the application. And with this information, we create this custom resolver instance, and we provide all the things. And in this, and then here, okay, we add the pattern that matches the current page to the with this URL resolver. So basically, what we do is dynamically create like sort of includes into the URL conf, and then this is the Django CMS URL conf just adds this list of URLs into the global URL conf. It works, is a solution that works, and it worked quite well for a very long time. At some point, I think that also Jonas tried to, Jonas Obris is one of the other co-developers, tried to change the way Django handles the URL conf to make this code cleaner, but yeah, like other attempt to clean up the URL conf failed. But it really, the only major issue that used to be was that whenever you add a URL conf, whenever you add an Haphooks to a page, you have to restart the Django instance because the URL conf are loaded at startup time. But we have solved that. First, digress and let's see a few improvements in this area that Django CMS has done in the past year. Basically, they are all very new. The first one, which appeared in 3.1, is namespaces configuration. Right now, you can have